range.
Yeah.
So remember what range is?
Range is the vertical distance, the horizontal distance between 2 points, the starting point, the ending point.
Right. So we're going to talk about A and B again. And that parabola is not sort of perfectly drawn, but you get the idea. We're focusing now on this distance here.
Yeah.
In other words, AB, the distance AB. All right.
Yeah.
So now we want to find range. Again, obviously that does depend on what the velocity and the theta is. That will change. But for any particular v and particular theta, once we know those, we should be able to find the range on level ground. So any ideas how we'll go about doing this?
Wait, would you mind writing the 6 formulas for me again?
So keep in mind your formulas. It's not so much the formulas that are important. We will obviously need them. It's more just thinking about which one do we use, right? Do we want to consider the acceleration, the velocity, or the displacement in the vertical,
The
in the horizontal
displacement.
direction? Or
Displacement.
if we are after the acceleration or the velocity or the displacement in the vertical direction.
But what we just found is time flew, right?
Yes, we found time of flight
yeah.
earlier.
Yeah. Okay.
So now
So
we want to find the
yeah.
range. How would we do that?
Thinking about it. Find the range. You know that SV, SY equals there.
So you might want to have a think about what we just worked
Equals,
out.
yeah, SY equals to there. What we just worked out is the time flight.
We just worked out the time of flight earlier. And
Yeah.
you should pay attention to the fact that I mentioned that for all of your equations, they're all equations in t, which is time. Okay.
Yeah, okay.
Which means,
Oh, you can just do it straight away. Yeah.
as I was saying earlier,
Displacement, yeah. Use
key
the
thing,
SX V times it by the T we just derived times it by
right?
cos theta. That's it.
So, as a key point that you should sort of recognize is that all of these equations are equations in t,
Yeah, they are.
which means that really when we're using these equations, time is your variable. So you really want to focus, and this extends to projectile motion questions done in this way, which is a focus in physics. You want to find
Yeah.
time. Time is your key thing. So if we did not find the time of flight before, then basically the way to find range is firstly to just find the time of flight. In other words, to find the t, right?
Yeah.
And how you do that is, up to you. We've already covered how we would do that, which is, in my case, let the vertical displacement equal 0 and solve for t, and then discard the t equals 0. So we'll have time of flight, which we've already done the earlier page, so I won't do it again. But the time of flight under these conditions here is just going to be 2v sine theta over g.
Yeah.
And then you were saying, what do we do?
It's just V times it by 2V sine theta over G times it by cos theta.
Yeah. So we're going to sub the t equals 2b sine theta over g, which is time of flight, into the SX formula, and that should give us our range. Does that make sense?
Yeah. Yeah, makes sense.
All right. So let's do that now. What will we get?
You will get V 2V squared sine theta cos theta over G.
So that's going to give you v squared times 2 sine theta cos theta over g, and that's not wrong.
Which is V squared sine 2 theta on G.
Right. That's usually the form we leave it in. So that means, therefore, the range is under flat ground conditions b squared sine 2 theta over g.
Yeah, I know this might be too early to ask, but what happens when it's not flat ground?
Well, we'll leave that when we'll talk about that when we get there. But
Okay.
what happens then? You'll just that means that you won't be able to use this formula. But what you can
Yeah.
do is use the same techniques, right? You'll still need to find the time of flight on the new conditions, but then you still sub in. So that's why I keep saying the technique is more important than the formula. The formula is great to know, but the technique is more important, right?
Yeah, okay, makes sense.
So the
Yeah,
technique
that's
is exactly the same. You're going to have to deal with different, displacements. So the displacement won't be 0 anymore, say, but you'll still find the appropriate time and then, sub it in, right?
yeah, the thinking is the same.
Exactly.
Yeah.
So that's why the steps are vital. And most certainly, you almost always have to show the steps anyway. Like so the basic questions are to do that. All right.
Yeah.
Okay. So that is your range for a level ground flight launched at V at angle theta. It will be
Yeah, I
V
think I
squared
have an
sine theta.
idea of how you can do the height.
Well, let's do that now. So now we want to find max height.
Yeah.
So now
But
that we